Okay, I've done a few trial runs, but I think I'm finally ready to video record my first YouTube video for my students in AP Calculus AB. And this video is going to be on differentiation of exponential functions. There's one learning target that we're going to focus on, and that is how to differentiate natural exponential functions. We're going to take a look at theorem 5.11 and example 3, which are right here. Theorem 5.11 is the derivative of the natural exponential function, and it says that if u is a differentiable function of x, we've got two rules that we can use here. The first rule is really not very useful because the derivative with respect to x of e to the x power is only going to work if the power is just x. And the second rule there can actually be used to find the first rule. So the second rule says the derivative with respect to x of e to the u power is e to the u power times the derivative of u with respect to x. Now, I'm going to rewrite this derivative rule as e to the x power, or excuse me, e to the u power times u prime. And basically, this is just using the chain rule. So the derivative of the natural exponential function is the natural exponential function times the derivative of the exponent. And it really is a simple rule to use. And by looking at this rule, rather than the first one, you can apply it to any natural exponential function, even if u was x, because then it would be e to the x power times the derivative of x, which would just be 1, and that was highlighted back here. Very rare that that happens, and even in the curriculum map for Unit 7, on the back side you'll see the Chapter 4, 5, and 6 review notes, and I don't even mention the derivative with respect to x of e to the x power because it's rare that that happens, and this rule that I'm sort of scrolling over here is much more useful because, well, it applies to any function with respect to x. So let's do a couple examples here. The derivative with respect to x of e to the 2x minus 1 power. What would the work look like for that particular example? Well, the first thing you have to recognize is that 2x minus 1 is our u function. So it's not the u that you're thinking of in terms of u subs. We don't use u subs for derivatives. We use u subs for integrals. So let's just talk about the derivative of this. The derivative of e to the 2x minus 1 power is e to the 2x minus 1 power times the derivative of 2x minus 1, which is just 2. We're going to rewrite and put that coefficient 2 out front. So we get 2e to the 2x minus 1 power. Really nothing else that we can do to rewrite that or simplify it. So there's our final answer, and that was pretty easy. Our second example, derivative with respect to x of e raised to the negative 3 over x power. This time, our u is negative 3 over x, which I'm going to rewrite as negative 3 x to the negative 1 power. And the reason that I rewrite that is because I know I'm going to have to apply the chain rule to find u prime. And by rewriting it as negative 3x to the negative 1, I can apply the power rule very easily when I take my u prime in a minute here. So the derivative with respect to x of e to the negative 3 over x power is e to the negative 3 over x power times u prime, which, using that power rule I had mentioned, negative 3 times negative 1 is positive 3, and x drops down to the negative 2 power. Couple ways we could rewrite this. This is one big product, so I can write this as one fraction where 3 is in the numerator. X to the negative 2 power moves down and becomes x squared. And e to the negative 3 over x power also has a negative exponent and can move down and become e to the 3 over x power. more than likely that would be the answer I would expect to show up on a multiple choice question. But as I scroll down and look at the scanned in answers, you can see number 1, the answer that I have circled, is the same as the answer from the scanned in solutions. Number 2, however, they left e to the negative 3 over x power in the numerator. I can't really see that happening, to be honest, but you never know. You got to be able to write your answer in equivalent form. So both answers are correct, and just have to work with your properties and simplify to get to the answer that you see in the multiple choice. So that is the derivative of the natural exponential function. Again, pretty simple to use, and you've got a couple examples here that show how it is done.